everyone. Please
Hey, good evening, everyone. How are you?
Hi, good
Folks,
evening.
can you hear me?
Hi, good evening. Doing good. How you doing?
Hey, all right. Cool. How are you guys doing today? Hey,
Hey,
hope
hope
everyone is
everyone.
on.
Yeah, we're good, Abhilash.
Cool. All right. Cool. So let's get started by. I think we have a lot of topics to cover today. Bunch of them, like a couple of them, are important from a, from a, I would say, job interview or daily work perspective. Lot other are, mostly from a data engineering kind of a perspective, or really advanced stuff that generally we as analysts don't use, but it's good to kind of know. And my honest answer there is, it's good to kind of know that when you need it you can google it, right? But uh, most of those things will be done to you by, like, provided to you by data engineering teams in your companies. So we'll cover that. But yeah, before going there, I'll just take maybe 5-10 minutes to take any questions that you have from whatever we have discussed so far.
Abhilash, I have one question. Uh,
Sure.
when we do the group by right, so whichever column you are using, selecting those columns, also we have to be use it in the group by also, right?
Yes, I mean, let's say in our example, we were using, let's say, subject and grouping by subject, and then summing the marks. So you have to group by subject. If you group by subject and if you group by section, so it is for each section and for within section each subject, what are the total marks? Then you will do group by subject and marks.
Okay. Mm.
Was that your question?
Yeah, that's what I mean. Whatever we are using the columns for the, I mean, in case if you want to place some names or anything, that also come part of the group by, right? Whatever we are using.
Why don't you share your screen and maybe write that small query and ask the question. Maybe that will be better for everyone's understanding as well.
Yeah. So I tried this one. I don't know where is it. Not here. Yeah, here, just wanted to try this instead. I
Basically, you're saying, can you do group by two? No, you need to do group by 1, 2. So one means name, two means
yeah,
subject.
yeah. Um, I don't know why I'm getting,
Results.
yeah, this too, because I just used,
Yeah. So if you do one thing, just in the first one, just say group by name, and the second one, just say group by name, comma subject. You'll see the difference between the two.
but somewhere I got the different answer for both of the queries.
Yeah, you will, right? So the first one is you're grouping by just name, right?
Yeah,
So maybe just put a where condition of name is in Abel and Ada, so that it's manageable. Put any, basically, just take two common names so that we can see what is happening. Or just take two names. So in
okay.
it's two names so that we can see what is the difference. Okay. So see, in the first one, you just grouped it by bread, right?
Mm-hmm.
And so second one is the first. Let's go to the second one because it's the correct one. So you're saying name and subject, which is
Yeah.
name is bread, and you're getting everything correctly, right?
Mm-hmm.
In the second one, what you have done is just like the first one. Now you're just grouped it by name. So if you total the, let's say for bread, just total, let's see, 92 plus 53 plus 38 plus 87. How much does it result?
Yeah, it's the 270. It's, I think, yeah, that's what
Correct?
the first one. Yeah.
17. So that will be taken up because you're taking the sum.
Mm-hmm.
But when you are grouping, you are just grouping by name, right? So the first one is essentially correct if you look at it at the name level because you're grouped
Mm-hmm.
at a name level. But subject, it is just picking up something randomly. So in this
Okay.
case, probably something that is, first or last. Okay. If you do the reverse, just do the reverse, which is subject. Instead of name, just say subject. Write the third query where instead of grouping by name, just group it by subject.
This one?
Yeah, sure. I mean, it'll work. Group by subject. Yeah. So just run all three. Right. Just scroll. See here. Did you just yeah? So here basically you got the four subjects. So now your score is correct at a subject level, which is English is 147. Okay.
Okay.
Now the name, in this case, it is just taking the last name. So in the
Okay.
order, whichever is the last one is taking, right? So this is picking up randomly. So this
Mm-hmm.
behavior you cannot predict.
Okay.
So that is the first thing. The second thing is this behavior is only specific to SQLite. When you go to Databricks or Snowflake or a little bit of modern or maybe it is a modern but like advanced RDMS systems, it will throw an error.
Uh-huh.
Okay, so it is dependent on which SQL dialect you're using as well.
Okay.
But just trying to explain what is happening here, this is more dangerous because this is returning something instead of throwing an error, it is returning something. Correct?
Yes.
But what
Yeah.
it is essentially saying is that, hey, you asked me to group by name, so I grouped it by name. You did not ask me to group by subject, but you are asking the column subject. Correct?
Mm-hmm.
So I'm going to
Yes.
pick
Yes.
something random in the
Yes.
subject and give it to you.
Yeah,
That is
that
all
is
it is
what.
doing.
Yeah, that is what my question was. I want to display something, but I want to group by only by name or any one specific thing. But I want to display three more columns.
So you want to display three more columns, which is English, history, maths, and science.
Just just saying I want to display name, ID, subject, but I want to group by only one thing. So is that possible?
Yeah, yeah. So basically, you'll have to join it back now. So the way to do it is, again, write this as a subquery,
Okay.
right? So just write remove subject
Mm-hmm. Okay, I
and
got it.
then join it back on your original table,
Okay, so there
right?
is
It's like
no
a self
straight.
join. Yeah, it's like a self join of sorts,
Okay, okay, okay,
right? So you kind of created a group table first, an
okay.
aggregate table, and then you join that back on the original table,
Mm-hmm.
right? Of the ID, which is in this case, it will be name.
Okay.
Yeah, you want to give it a shot?
We'll try that. Yeah,
Let's do
we'll
that.
just want
Just
to.
keep,
Yeah,
yeah, go.
we'll do with this.
Yeah, just work with like a smaller data set so that it's visible as to what is happening.
So I want to display. In case I want to display ID as well. So, but I just want to name. Group by subject. Is that okay? Or name, group by name, and then I want to see the score, but I want to display ID, name, subject, and score.
No, so what is the score level at? So firstly, the group by, what is it you're looking at? Are you looking at a subject level or are you looking at a name level, student level?
Name. Because for this name I want to know what is the total score for
Okay,
name
so
level.
so basically the first query that you've written, line number 45, just remove subject from that first. again, go step by step, right? And just name scores as total score, right? Yeah, just run this query first, 45 to 48. See, so you got Brit and Buffy, you got the names now. So this becomes your subquery, right?
Okay.
Correct.
And
Now, yeah. So now write your original query, which is you want what? ID, name. You want ID, name, and you want subject as well.
not subject because it's a total score. I am not sure. Or ID
Okay. So
name.
so
Okay.
ID need you can just group by ID here itself, right? Because ID and name are unique in a way.
Here
So if
you
you
mean?
just need ID and yeah, if you just need ID and name, you can just group by ID and name.
Okay.
So okay, let's do what I'm saying. Just say ID name, comma subject, comma score, right?
Okay.
And comma, just take total score as well, comma total score. Okay, just say from scores, right? Just name, yeah, just do a join first. Just do a left join. Yeah, just write, open a subquery. So open close brackets. Yeah, just go down, remove, yeah. Instead of name, just group it by ID because names are duplicated. Also, this will not matter here, that's fine. So group by name, just enter and give the join condition. What are you joining on?
Same ID.
You don't have ID in the subquery, right? So you need to join it on name.
Yeah. So
Just
here,
name
do I need to
yeah,
give alias?
yeah, you can give an alias or name it.
Okay.
Just call it a, this is total scores, right?
I'll
Yeah,
save.
yeah, fine. First and second.
First dot name equal to second dot name.
Yeah, okay, just run this. It might, ID and names are, common, so it might throw an error. Yeah, ambiguous name. So just ID, name, subject, and score. Just basically name. Just call name FIR name because name is common in both your tables. Right? In the select statement, select ID, comma FIR dot name
Oh, okay.
because name is common in both of them. So run it now. Why is total score coming out to be? This is weird. Left join this on first dot name is name. Just put, yeah, a lot of them will be null because you don't have a where condition, right? So just put a where condition again after join. So this where condition is on the first, like the entire table that you have created, right? So just put, yeah, you can just put this as well. Just copy the where condition downstairs. I mean, after on, it will work. So folks, why are we getting nulls here? Just a quick question.
Because where condition is only on Brit and Buffy. For this.
So we'll get, so just a minute before running, just show everyone that, wait. Yeah, just show everyone that when you look at Brit and Buffy, it will not be null. Whereas for all others, it will be null. In the results that you have got on the right hand side.
Yeah, everything is null.
Yeah, no, you'll find the numbers for Brit and Buffy. Just maybe page 21, right? Just order by name so that Brit and Buffy will come up top. Just remove this where condition. Or, no, you have to order by name or FIR.name. Yeah, makes sense. Just run this once. No, do ascending because you need D at the top. Okay, so just scroll down now. There are a lot of A's as well. Just see there's a pagination arrow at the top.
No,
Go at
it's
the top. There's a pagination arrow. Just move right. Still A, right? Just go to B. Just keep clicking till you get B. Yeah, so go back. So just see here now, Brit and Buffy.
yeah.
See, for
Yeah.
Brit, you got 270, and for Buffy, you got whatever, 215, right? So because in your inner query, only Brit and Buffy were present, those rows got populated, and rest of them remain null. Why? Because this is a left join, correct? If you do an inner join, just do an inner join now, instead of left join. You'll only get rows that are common between both tables. Right? Run this. See, you got it, right?
Yeah.
Okay. Everyone understood this?
Yes.
Now let's go one step quickly further. Add one more column in the select one. Just say percentage score or share, right? A score share, comma. Just do score divided by total score divided by or slash total score. So once you have these columns, and just name it as maybe score share. So if you want to know of the total score that a student scored, how much was the contribution of each subject, you can just divide the two columns. Okay, just run
Yeah.
this. Okay, now you got the share of each subject in the student's total score. Okay, this
Yeah.
essentially is, now you're getting into territory of analytics, right? So let's take one step further. Now your score looks like, a long number, right?
Yeah. Make
You
it a
don't want that.
percentage.
Yeah,
Make
so
it
maybe just round it. Just say
round.
round. Yeah, round should work. I mean, again, this depends on which these change a little bit here and there, but is round working? Round, you have to probably do like round comma 2. So you have to give the number of decimals
Yeah.
that you
Yeah.
want. So just do comma and 2, right? So what this is doing here, it is rounding off the score to 2 decimals. Okay, so this literally is one of the topics today. So we are running into basically analytics a little bit. So you got 0.34. Now, if you really want to convert into percentages and 2 decimals, just multiply score by 100. No, I mean that will, so this will be incorrect, right? Because you're rounding first and then you're multiplying, so you'll get 34. And you'll miss out on the, just try this is good. Just try this, see what you get.
Yeah.
So you got 34.0, 32.0, right? Because you rounded first and then you multiplied by 100.
Okay.
But if you want the precision to be there, like let's say really 2 decimal places, you should multiply the column first. So basically 100 into score divided by total score. Right? And now whatever result you're getting, you're rounding it off to 2 decimals. So it will give you the precision that you need. Okay.
Yeah.
Got it? Is everyone clear?
Yeah.
So this was an example of what? Division, right? You can do all sort of mathematical operations. You can do addition, subtraction, multiplication, division, right? You can take absolute values, you can take modulus, all those are there, and that you can just read up in the documentation. So if you can Google, Shanti, just maybe like open your browser and Google.
But
Before you do that, can you please do one thing, Shanti? Can you
Yeah.
please remove name from inner query and see what happens if it throws an error?
Because we are joining with names, right? I don't know, maybe.
Can you try doing that? Just see.
It will throw an error.
Throw an error.
Yeah. No, it
Okay.
will throw an error
New
because of
column,
two
because I
reasons.
don't have a column name, because I joined.
So just run the inner query, select and run the inner query that you have written here. So what you are doing here is you are creating a temporary table or a view, right? It's not a temporary table, it's called a view. So you are creating a view, and in that view, essentially, just run it. You don't have a column called name. Now, if you don't have a column called name, and you are asking on line number 52 to join it on name, it will say that we don't know where the column is, right? So if you read the error, it says no such column, second dot name.
Oh, okay. So
Correct?
that means the SQL program does not automatically because there is still name column in the table we have mentioned, right? But it does not do that automatically.
No, it is there in the scores table from where it is picking, and hence it is grouping it by, right? So we are saying group by name, it knows that name is there and it is grouping by that. But as soon as you put it under brackets and you call it SEC, right? Second, you have renamed it. The second table doesn't have name. Correct?
This is like a temporary table, something kind of.
As SEC.
Right?
Okay. I forgot that.
So SEC doesn't have a name. The inner table has a name, and if you see, it has recognized that it has a name, and it is grouped by correctly. You get the same answer, which is 270 and 215.
Oh, okay.
Correct? So there it is working, but because now you have forced it and you're telling SQL that, hey, this is the table and I want to call it section or second, right? And now you're telling them that second should have a name, it will say that it doesn't exist, right? The name column doesn't.
Okay. Yeah, can you please paste the original code in the group chat and
Yeah.
yeah.
Where is it? Maybe I'll do it after, because I don't know where to do it.
Okay, no problem.
There's a chat window. Fine.
Yeah, because I don't know now. I'll do it after this.
Oh, okay. Yeah, no problem. Take your time. Yeah.
I will share my screen now. So, okay, folks. So I just wanted to show a little bit of like how do you kind of see the documentation and all. So I just Google SQLite operators, right? So this is not the official documentation, but in general, this will anything will work, right? So if you look at command syntax data types, right? So in here you have all these data types that SQL has, right? SQLite, this is SQLite, correct? But if I just do the same thing for Postgres, right? So let's say Postgres data types.
We are seeing your WhatsApp thing.
Sorry?
It's, we are
So you're
seeing your
seeing, you're seeing
WhatsApp.
WhatsApp window. Okay, no problem. Maybe I am sharing my desktop, so it should work now. Okay, can you see it now?
Yeah.
Okay, so essentially I looked at SQLite data types. So you have null, integer, real, text, and blob. Whereas if you look at, this is official Postgres documentation, right? So let me just go here. In Postgres, you have much more. You have Boolean, you have characters, you have numeric, temporal, UUID, arrays, JSON, right? So arrays and JSON also you can store here. So this depends on which SQL type you are using, right? So general thing is just always, look at your documentation, and depending on what SQL you are using, generally you will kind of need to use those syntax. Most of the syntax will remain the same. It is just that slightly things will go kind of here and there. Okay. All right. So I just wanted to maybe touch base upon one more thing here. So useful functions, maybe count, max, min, you have length. So you can see here, right? We had used count, max, min, average, sum, but there are also functions like random, which will pick up any random row, absolute, which will just take, either it is positive or negative, the value will be, +3 or -8 will be +3. Upper, which will just convert into uppercase, lowercase. So you can go through all these, things at your own pace and just try various things, right? So just Google, you'll get your answers mostly. I wanted to cover one quick thing now. So continuing on this analytics, in a way topic. So we did one thing yesterday, which is the max, figuring out the max number of, sorry, the max, I would say, marks, right? So the question is, for each student, find the subject in which he got the maximum marks. He got the maximum mark, right? So how did we do that? So first of all, let's just look at scores. So you got everything here, and just for simplicity's sake, right? Let me just take where ID in. So let's take Bronny. And I think we had Brian, right? Brian was doubled, right? We had two names for Brian, I'm guessing. Yeah, so 85 and 146, right? So let's take 85 and 146. Okay, actually, let's take Dory as well. Okay. Okay, so we had Dory, but it's 168 and 18, right? So let me just take 168 and 18 as well. Okay, so we have these many students here now, right? Let's get rid of a few actually, because it's just becoming too much. So let me take this. Okay. So we have these many students. How did we get the max of it yesterday? So we said that for first is we calculate the max, which is for each student. What is the max score? And we call it max score, right? From scores. So once we have the max score, we said that order by I would say max score, and we said that limit is equal to limit. We cannot do limit because we just do this. So let's kind of run this first and see if this is working. Right. So here we are getting group by. So for the students we got the max score, right? Now we got only 3 names because they are duplicated. So let's do ID. And here we got it for each of the student, right? Now, we got the max score, but we don't know the subject for this, right? So what we did, we went back and we said, hey, again, give me the ID, the name, and subject from each of the, basically from scores, correct? And essentially, I'm joining it, right? I'm saying that join it on this table that I created, right? So my subquery in a way, and I'll just call it max score, right? So MS on what I want to join it on, sc.id is equal to c.id, Okay, so this will give you the ID is okay, no problem. And essentially, let's take score as well, right? So you got for each student here, the subject dot score. Okay, sorry. Here we need to go. Okay, the ID and the subject, right? So sorry about this. And you need to join it on only the subject which matches the score, right? So we want sc dot score is equal to my max score, right? So I'm saying wherever my max score is matching with the student, just pick that. You need and okay. So you got it for each of these subjects. Am I still missing something? So this one is returning.
I think we need to add the where condition after that.
Yeah, but it's just okay. I'm doing a left join, right? I'm just doing a join. Again, the same issue. Run the selected query. So you got each one of them, and just to be sure, I will just take the max score as well. Right? So you see that we got all the subjects where the student got maximum scores. Correct? This becomes problematic. Let's say that you want the second top or the third subject or the fourth subject. How will you get that, right? It's not possible to figure out everything, right? Here, maybe you get max, maybe you get minimum. But let's say I want the second one or the third one. So which is a subject where the student did second best, right? That becomes difficult to do. So for that, we have something called as window functions. And let me just quickly give an intro to window functions now. So let's just look at what we get here, right? Okay, so we got, let's not do this. Let's take the subject and let's take the score. Okay, so here, is there something that I'm missing? Maybe let's run this. Okay, so you got for each student, you got the subject and you got the score. Now I want to rank them, right? So within this, I want to create another column where for each of the student, I want to know which subject he got the least marks and which subject he got the most marks, right? So this is called as window function. Why is it called window function? Because in your data set here, you are creating a window which is of a student, and within that student, you are running an operation, right? That's pretty much it. So let's look at it first, what the function is. So we want to rank, right? Rank or row number. So let's do rank. This is the syntax, so don't worry about it as much. Excuse me. Okay, so we'll say rank. So this is the function, and hence we have curly brackets here. And it will ask you over what, right? So what is it that you want to rank it over? What is the window? So you'll define a window here, and the window will be, you have to define a partition, which is like a group by. So what is the partition that we're creating here? We are saying that my window is just this, which is at an ID level. So all IDs which are similar will be considered one window. This is very similar to group by, right? So instead of group by, we say that ID it partitioned by ID, and after that, once you have defined the window, it will ask you what you want to do. Like here, you want to create a rank, right? So rank by which order? So you have to rank it by score, correct? And we'll just say this as rank or subject rank. Let's run this, and then again, we can see what is happening here. So if you run this, ID saying there's an error near ID, prepare near ID syntax. Let me just quickly check what am I missing here. There is Okay, I need to do order by. And think I need to do partition by as well in this case. Yeah, so I just need to do partition. So syntax is essentially not partition, partition by. And let's run this now and see what you got. So you got for each window, it scored it, right? So history is the least one. So you got for 1, 2, 3, 4. If you want it to be scored in a descending order, like you want 1 to be the maximum marks, see, now you get 1 is like, so you got the highest marks in English, then math, then science and history, and then English, history, math, science, right? So for each student did that. Now let's look at partition, right? Why partition is important. If you, instead of ID, if you partition by name, what will happen? Can anybody guess?
It will include the duplicate as well.
So the rank will kind of move from, so if you look at it now, all Brians are ranked together. So we get rank from 1 to 8. Correct? So it just ordered by score. So what it did essentially was it said that, okay, what is my window? My window is my partition, which is name. Correct? So it took all the Brians, then it ordered all the Brians based on score, and it just ranked them. Correct? So that is why partition is important. If I don't give any partition, it will just order all the rows that you have provided. Okay, so look at it now. All the students, all the subjects are just scored in a descending order. Correct? So as soon as we do a partition, so giving the right partition is important. So let's say I do a partition by, but I don't, let's say I want to now look at differently. I want to look at for each subject, which student got the highest and lowest marks, right? I don't care about like the student. So I want to partition it by subject. So I want to create a window of subject. And now if you look at it, English is grouped together. And we had 5 students, right? So see, 1, 2, 3, 4, 5. History is grouped together, and we get 1, 2, 3, 4, 5. Okay, everybody's clear on this, how this is happening? Now, let's say, now it becomes very easy, right? Because you have this, you can just say that, okay, now I want to look at which student scored the highest mark in English in each subject. So I can just say subject is equal to, subject rank is 1. And as soon as I do that, okay, basically it will say, rank you cannot use directly in the subject, like directly in the where condition. You have to use either subquery or, so I'll use a common table expression. I will create a view, like a temporary view. And once I have this view, I will now say that select, what do I want? I want ID and name and subject and marks. Marks we don't have, like we have score. And I want the subject rank, and simply where subject rank is equal to 1, because I want the first student. And which table is this coming from? This is coming from the temporary table that I created upstairs. I think this is a keyword, so let's use temp underscore. Right? And so now you got first, right? So you got all the subjects where the student which got the did I partition it by subject? Yeah. So Brian essentially got the highest marks in each subject anyways. Correct? Let's look at who are the students who got second. So in second, again, Brian is the highest scorer in all the subjects, like second highest scorer, apart from English. In English, Dory scored the second, highest marks. So this is a different Brian, by the way, right? This is, look at the ID. Maybe, yeah. I'll just remove the name and ID. So here it will be better. So student number 18 is highest in English, 146 in history, 85 in maths, and 85 in science, right? So 85 is Brian. Okay, people got this? Everyone got this?
Yes.
So first, so did we understand what your, so 2 things, right? Did we get what my like window functions are? How are they, like what are they doing? So this is what they're doing, essentially ranking. And then, we can use that to kind of just select everything, like as a where condition to kind of sort everything out. Okay, we good?
Yes, but this partition by work with different functions, right? Now, in this case, we used rank.
You can use other functions as well. Yeah. So basically, your function will keep changing, but this syntax remain the same. So this syntax defines what your window is. So it defines two things. It defines what my window is, which is partition by, and then it needs like the function to operate on which field it will operate on. So here it will operate on score.
Okay.
So instead of rank, if I do row number, it will work as well. Right? So row number and rank are the similar kind of a thing though. So you won't see any difference. Right? So row number, now it becomes subject rank. Okay. There are other window functions. I will just maybe demonstrate one more. Again, SQLite has till very recently, SQLite did not have window functions, but now they have introduced it. So it's really good, right? So let's look at what do we want? We want, okay, so maybe like first value. Let's use, okay, let's use this entile, like percentile. So if you want percentile, okay. Okay, let me just quickly look what entile kind of does. Given results in a number of buckets, see what the percent bucket in each row. Okay, so it is dividing it by bucket, maybe like percent rank then. Of course, these functions, their use depends on the use case, like what you're doing. Or maybe let's do like last value. This will work. Wrong or average function last value. It doesn't give you what am I missing here. Okay, you have to give like sorry percentile. Okay, so let's just run this. So now it is essentially calculating the percentile of each of the, we have done it by subject, right? So it is calculating percentile of each of the for each student, sorry, for each this thing now. So if you look at it, and let me order it as well. I think this also will not work because subject once like, oh, it did, all right. So if you look at it, what it did for each, we had created a window, and for each subject, basically we created a percentile, and we asked them to give the percentile score of 1 to 4, correct? So if you look at it now, all the subjects with high, like till this point has got 1. I need to order it by, let me, sorry, subject comma, subject rank. Okay. So if you look at it, my window is English because my window is subject. For each subject, it ranked the students in percentile. So 80 percentile is something like, you understand percentile, right? Everyone? Essentially, it creates bucket, and for each, for example, here the percentile is 1 to 5. It will basically divide the range into 1 to 100 into, how do I put this? Maybe, so think about it like this, which is the highest students are grouped together, they get the same percentile, and cutoffs are drawn, right? So it takes logical cutoffs based on the values that you're providing. So here the minimum is 4 and maximum is 95, and we have asked it to convert it into 4 buckets. So it converted those 4 buckets into here above 89, like somewhere around 40, above 41 and below 89, then above 5 and below 41, and then 4, right? It's more evident here. Here the buckets are slightly better. So you see the cutoff is here, right? So you can try multiple functions depending on what you needed. So let me take maybe like a better example, which is percent rank. So let's try percent rank now. Generally, you will just use rank and row number, and I'll give you like a use case as to where it will be used. Okay, so it's better here, right? So if you look at it now, it is giving a percent rank. So anything which is first, it is giving 0. Here, I think we should do ascending. It's better that way. Okay, so what is the percent of this, right? So it is in the 0 to 25, in the first bucket, which is 0 to 25. 5 is 0 is 25%, 41 will be like 50%, and then 80 like 89 and 95 will be 75 and 1%. So basically it converted the rank into your converted the ranks into the percentages, right? So let's look at maybe look at rank and this thing side by side, and that will give you an idea. This is percent rank. Okay. Okay, so now you can see for, it just converted the 1, 2, 3, 4, 5 students into percentages, which is what is the percentage of this? 0, 25%, 50, 75, and 1, right? 100%. Correct? So you can do like a bunch of things with these, but the only useful ones are rank and row number. And the good use case of this is, let's say you're an e-commerce website, a customer is ordering multiple items, right? And you want to know what is the order in which the items were ordered or fulfilled. So you'll just say by partition by customer, and I want the sequence of orders. So you'll get it, in each in ascending order of date when the orders were placed. Now let's say you have category on the website, something like shoes, like other footwear, clothing, winter wear, and you want to see that what is the order in each category. So you can do partition by customer, partition by category, and then just rank order it, right? And you'll get that for each one of them, like which is the first order, which is the second order, which is the last order of a customer, and it really becomes very easy to kind of do any kind of analytics based on that, right? Or differently, let's say that you want to calculate what is the order value for the first order and whether it is decreasing or increasing as the orders placed kind of go keep increasing, right? Let's say in food delivery. So maybe the customer will order something low value to begin with. Once the trust is made, then the order value will keep on increasing. So how will you do it? So you'll just, so in this case, you can just now say, I want to group it by my rank and see what my sum is, right? So you can just say sum of score. Where you don't need this, you can just say group by 1. Correct? So now instead of subject, it will be order number. So what is the order value? Your order value is kind of increasing here, right? So these are the kind of use cases that you do, and this essentially helps a lot with when you're transforming this data for any kind of analysis, or maybe like for dashboarding, visualizations, or things like that. Okay, I'll pause here and maybe take any questions. Anything, folks? Is everything clear? Any questions? Are we good? Folks, are we good? Yeah, go ahead.
What is the difference between rank and row number? You said both are similar kind of thing.
Yeah, so row number is just, it will order by row. But let's say rank, if two people have the same score, correct? So
Okay.
here, if you look at it, Dory has the same score, right? Here. So if I just partition it by, I'll do a rank and a row number. So this is row and rank. And we don't want it by subject. We want our window is essentially now student, right? So let's say name, because they have different IDs. Okay. So now if you look at just Dory for 23, so look at this. The row number is 3 and 4, correct? But the rank is 3,
Okay.
correct? And because now you got two people, even like in first one, right? Science and English, they are ranked 1, basically lowest ones. But because now you got two ones, the next rank will be 3, not 2.
Mm-hmm.
Correct? And you got 2 3s, so next rank will actually be 5.
Okay.
And so forth and so on, right? So this helps, that's the difference between rank and row number.
Okay. Okay, thank you.
Okay, all right. Should we move ahead? Okay, all right. So let's move on. So the last topic that I want to cover is, schema and normalization. Okay. I'll just take a quick break. I need some water and I'll come back. But essentially, that's what we're going to look at. Okay. Give me 2 minutes, folks. Hey, folks, sorry, I'm back. All right. So let's first look at database designs. Okay. Can you see the Google Sheet?
Yes, yes.
Okay. So we had these two, I would say, tables, right? So we had students and then we had scores. So generally, when you define databases in SQL, these are relational databases, right? So what that means is one table is kind of related to other table in via some kind of a some kind of a column. or a key, correct? The other thing that we try to do is we don't try to repeat any kind of data, right? So this is basically called normalization. And the reason for that is, as you can see here, you have, let's take this, right? So you have these two students, and then you have scores as well for them. But as you can see, the name is unnecessarily repeated here, right? So you have a name column here as well, and you have a name column here as well. If you don't have this column, then also you'll be fine, right? Because if you want to get any kind of a, at a name level, you can just join these two tables on ID, and post that, you can get a name from the first table, correct?
Yes.
So what this does is, what this is saying essentially is that don't repeat your information. It just helps in storage. Plus, there's other factor as well. Let's say you want to just change the name of Bronny because it's a spelling mistake, correct? And it's actually NY. Now, if you have this column in multiple tables, you'll have to go and update the name in multiple kind of tables, right? In this case, we have just two. But if you look at yesterday's mystery database, the names were repeated like probably in like 3 or 4 tables, in the license table, in the gym membership table, correct, in the login table. So you'll have to go and update it in every kind of table there, which is again problematic, because there is a good chance that you might miss out on some table, and then it will create errors, right? The data consistency will be lost, correct? So what we try to do is we try to keep information to the minimal, and we just use it once, and we repeat it only and only when we have to define a relationship. Okay? So in this case, ID is my common column between them, and that is how I'm defining the relationship. So technically, I should not have the name column here. I should just take it out. And essentially, this technique is called data normalization. So let's say you as an analyst is designing a database, correct? You as an analyst is designing a database for, e-commerce. So you can do the same thing. You have a customer ID, you will have a customer name, right? And maybe you will have age, you'll have gender, and maybe you also have like location or city, right? And then I can have an orders table where I don't need this, right? So I'll have a, so order table will have its own ID. So this is not it, but I need to have a customer ID, right? And this customer ID is this ID here. So let's say I've placed like 3 orders or 4 orders. All of them will be tagged to me as a customer. And maybe here I have just the, so think about this. I have a category. Again, I don't need category. I have a category ID. So maybe it is A, B, and C. Right? And then I have a item ID. What is the item that I'm purchasing? Maybe like it is 101, 101, actually no, 102. Then we have 201 and 201. Correct? Again, this helps keep my data to minimal. But what next? I've got a customer ID mapping, but I need a category ID mapping as well. So I'll have another table which will have an ID of its own. So this ID is for the table, right? If this is my category table, let's say, these are my orders, and these are my customers. Okay. Now, what is my category ID? Actually, let me just not do this, just for better this thing, right? So I'll have 1, 2, and 3, and maybe the category name is books, clothes, and footwear, right? And then we have literally the last table, which is items. Okay, I should have one more here, which is just putting something here, which is date, right? So maybe this is 2023-01-01, so January 1st, January 5th, then you have Feb 1st, maybe like I place another order on Feb 2nd, right? And you have items, so items will have an ID of its own. And so what are the IDs that we had? We had these. And what is the item name? Maybe this is a real item name. So maybe this is SQL for dummies. When we have clothes, so maybe it's like, I don't know, Van shirt. And then, Nike Jordan, right? So what you have done is you have just separated all the data and you have used it every data item only once, right? And you have mapped the tables across using some kind of keys. So there are two type of keys essentially. So for each table there will be a primary index or a primary key. Primary key is essentially unique to that table. So here the primary key is 1. Essentially ID is the primary key for all the tables that we have defined. But you can define a primary key as combination of things as well, right? Actually, it's not a good practice, but essentially assume that primary key is essentially the unique key of the table. It can be a combination, but generally it will be just the ID column of the table, right? So that's the primary key. Then you will have something called as a foreign key. So what is foreign key? Foreign key is essentially the common column that you are used to join the table. So in orders table, my customer ID is my foreign key. Why? Because if I have to join this orders table with customer, I will join it on customer ID. Is this clear? Similarly, category ID is also my foreign key, but it is with respect to some other table, which is called as the category table. And item ID is also a foreign key. Just a minute, I'm facing some audio issue. Give me 1 minute. Hey, can you hear me? Folks, can you hear me?
Yes.
Okay, all right. So this is my, foreign keys. Is everybody clear on what my primary keys and what my foreign keys are?
Yeah.
So essentially a primary key of one table can be a foreign key of other table.
Yeah.
Right? Any questions so far?
No.
All right. So one last thing that we need to understand here is mapping. So tables are mapped together, right? They are mapped together in multiple manners. For example, customer ID, let's look at the mapping between these two tables, which is customers and orders. Okay. So for each row in customers, you can have multiple rows in orders. Correct? So in this case, the mapping will be 1 to n. All this, again, this is a little bit theoretical and you generally won't be using it, but somebody might ask you in the interviews, right? So think of it this way, whatever I'm joining on, if one customer, like in the customers table, you have one customer, that customer can be mapped to multiple orders, multiple rows in orders, right? Hence the mapping is 1:n. Okay. So basically 1 to many in a way.
n is many, right? So I'll just call n or many. So can somebody tell me what is the order, what is the mapping between orders table and category table?
One too many.
Can you explain that?
So one order can have products from several categories.
Okay, so one order can have this thing of several categories. Make sense? So one to many. Similarly, but let's say that we are now looking at relationship between. Okay, we did not have a category of this thing, right? So one category can have many items can have. Yeah, so let's say now items. Here I have a category ID as well. So each item is classified as a category. Correct? So we have books, we have clothes, and we have footwear, right? So what is the relationship between items and categories?
One to one this time.
Sorry?
1 to 1.
1 to 1.
In-
Okay. Why is that?
No, I think it's one to many. The opposite.
Because right, it will be many to one because like all the items here, they can be mapped to only one category.
Yeah.
Correct. So many of these items. So if I have another shoes here, instead of Nike, let's say I have Adidas as well. So the category is like many of them are just marked to only one of the category. Correct.
Yeah.
So each one row cannot be mapped to multiple categories. They can be mapped to only one category, right? So each item can be mapped to only one category. So multiple items can be mapped to one category. But if you look at it reverse, one category can be mapped to multiple items. Is that correct?
Yeah.
So that is how you define the mapping, right? Simple. Just look at it. The first table that you're looking at. So categories. So what is the item, which is books? It can be, and in items you can have multiple books, right? So it is one to many. But if you look at it reverse, in items you can have let's say many books, which is SQL for dummies, advanced SQL. You can have data engineering. So these are all the books. All these many books are mapped to just one category. Actually, this will still be like one to, you can call it as 1 to 1 as well. The other thing can be, let's say that, okay, now assume that SQL for dummies is actually has two categories. So it is book as well. And actually, let's look at this, like Nike Jordan. So they are, it's shoes as well, it's footwear as well. But you can classify them as sportswear as well. Right? Sports as well. So now one item is mapped to multiple of them, right? So it's the category kind of changes. Let me actually look at examples which are better. Relational mapping in SQL. Here. So if you look at the orders here, right? You have two tables. Each row of the table A may be referenced by any number of tables in B, right? But each row in table B can only be referenced one row in table A or none at all, right? So if you look at it here, if customer is your table A, each row can be referenced by multiple rows here, right? So it's one to many. But if you reverse it, one row can be referenced to only one, row in the customer's table. So it's 1 to 1. Are we clear?
Many to
Just
one, yeah.
simply look at it. If I join it, right? If I join it, will the number of rows increase, remain the same, or decrease? Or basically, yeah. So if you join customers to orders, your number of rows will increase or decrease, or remain the same.
Number of rows.
If I
based
join
on
customer orders, my customer rows will increase or decrease from a perspective of my customers table.
increase.
Increase, right? So hence it is one to many. So
Mhm.
currently customers has one row. Once you join it, the new table will have 4 rows, right? Because
Yeah.
one for each customer. For each customer, you have 4 rows here. So because your number of rows increased, it's one to many.
Mhm.
Look at it reverse, right? Let's say for orders table, how many rows do you have?
4.
4. And if you join it on customers table, how many rows will you have?
4.
Right? So it is 1 to 1.
Okay.
Okay. If let's say that there are duplicates, correct? For example, so it will be interesting now here. Let's say that for some reason, I have one more ID and it is mapped to, by mistake, it is mapped to a new user with a similar name, or there is, let's say, a spelling mistake, correct? Now, look at it from a customers. So again, from a customer and a table perspective, your customer table has 2. How many rows will you have for your and let me for your basically ID is 2, but the name is kind of misspelled here. So and here also, let's say you have a name column. Right. So now instead of joining it on ID, you decide to, for some reason, you decide to join on name. Okay, and the name column is here. Where did it go? Okay, so and for some reason now there's a duplication. There's no spelling mistake, there's a duplication. You join it on name. So if you join the customer ID on ID, not on name, how many rows do you have? You have 2. The new table will have how many rows? 5. So you have 1 too many.
Yeah.
But if you join them on, so first look at it differently. First look at the orders table. How many rows do you have to begin with?
5.
Now, if you join it on ID, how many rows will you have? If you join it on customer ID, how many rows will you have?
With ID, it will be 1.
So it is 1 to 1. But now if you join it on name, how many rows will you have?
Name 2.
You will have for, let's look at it for customer. If you join it on name, here, ID and name, right? So if you join it on ID, you got this. If you join it on name, how many will you have? You will have Abhilash is joined with all 5. And this Abhilash is also joined with all 5, right?
Yeah.
Correct? So you'll have 10 rows.
Mm.
Correct? Now, look at it reverse. This Abhilash will get joined to both of them, and this Abhilash will also get joined to both of them. Right? So it becomes many to many because it will just bubble up now. So initially it was 5 and now it will become 10.
Mhm.
Right? So n number of, so 2 of them are joined to 5 of them here. Correct? So hence it is 2 to 5. So it is n to m, which is many to many. But if you look at ID, one ID is joined to multiple of here, so they become one to many, right? And reverse, if it is like one is joining here with one, you can call it as many to one, or it is basically, actually it is many to one because your 4 are joining to one. But you'll always look at it from either 1 to n perspective or n to m, like 1 to many perspective or many to many perspective. Okay.
Okay.
So customer to order is 1 to many, and orders to customers will be many to one, and items to categories, again it will be many to one, or it can be many to many as well, because one item can be joined to multiple categories as well. If there are duplicates. Are we clear on this? Simple way to look at it is one row can be joined to multiple columns, multiple rows, it is 1 to many. If many rows can be joined to one row, it is many to one. If many rows can be joined to many rows, it is many to many, or n to m, as they call it. Are we clear? Again, this is just theoretical questions. Generally, you will not be using it in any kind of your work, but people might ask what is the relationship between customers and orders? And you can have like 1 to many here. And if you look at it reverse, it is many to one. But if you are joining it on name, for some reason, let's say the primary ID or this thing is name, then it will be many of them can be joined to many of rows, and hence it is many to many, or rather n to m, in this case specifically 2 to 5. Okay, are we clear?
Yes.
Okay. That is it. There is one last topic that needs to be covered, which is around indexes itself. So we'll move on to that if there are no further questions.
I have a question. So while setting up a table, how would you determine if which one is foreign key? Like in the create.
Correct. So primary key is clear, right? Primary key is something which is unique to the table. So you identify in orders, it will be order ID. Like I can call it order ID, but generally, I'll call it ID. And because it is orders table, it will be orders.id and it will be identified. But okay, order ID is my primary key. My foreign key will be all those keys on which I need to map, or I need to kind of create a relationship. So in this case, customer ID, it's mapping to some other table. So it's my foreign key. If category ID, if it is mapping to some other table, it is my foreign key. Age is not mapping to anything, right? So it's just a normal column. It's not a key of any kind.
Okay.
Understood?
Yeah.
I will probably let me put it this way. So you have, let me transpose it, right? So you had customers. You had orders. So this will generally be like a question in, database design or something like that. So you might not be this thing, but somebody might ask, because it's important in joins, they might ask you to identify the relationship, whether it is one to many or one to one. This is only from a join perspective. Like mostly they'll ask you from a join perspective. So they will not get into explanation. They'll probably just give you two tables and they'll ask you to kind of identify the relationship, right? So here's the thing. So these are the tables. ID becomes my primary key. It's either ID or it's like order ID. So I'm just keeping both. usually it will be like a call ID, because again, you want to reduce the number of like the column names, they need to make sense. Name, we are not joining anywhere. I mean, here I have, this is not the name. So this category name, this is, let me call it item name. Right? Okay, this is good. Let's do this. So here also there is a name, and here also there is a name, but this is a customer name and this is an item name, right? So they are not the same, they are different. Correct? Now, this customer ID will be a foreign key, or the other way to look at it will be like it will be mapped to a foreign key. It's a foreign key and it is mapped to this ID. Correct? So this is my foreign key mapping. Similarly, if you look at ID, category ID, this is my category ID. It's mapped to my category ID, right? This is, so the foreign key category ID here is the primary key in category table. Correct? Same goes for items. Item ID. Correct? So these are my foreign keys and these are my primary keys. And because name, age, and gender and city are not like mapped anywhere, they are your normal columns. Understood?
Yeah, I understood that. I was just asking if you, whenever you're making a create SQL, right? So in SQL, you're creating a table,
Yeah.
and how would you determine that it,
Okay,
or
got it. Text basically, right?
yeah,
Yeah, I'm getting to that.
okay.
So now, basically now one last, concept that is remaining is that of an index. Okay. So what is an, so we have learned three things, like, so we know what a primary key is, what a foreign key is. Okay. But what are indexes now? So indexes are special like columns on which we can, we can tell that, so I'll give an example and then basically we can look at it. Wait a minute. So first of all, to answer your question, Prinsa, this is how the syntax looks like, right? So what we did yesterday was we created a table right here. So while creating this table, you're giving, ID, name, like these are the data types that you're defining. After you define the name, you can tell what my primary key is, right? So in this case, it will be like, excuse me. So, okay, there is a constraint. Just let me see what constraint is here. This is slightly different than the usual primary key. Yeah, so essentially if you are creating like a combination, right? So let me say here it's my, let's call it ID and name. So your ID and name is column is unique. So you can say that my primary key is actually my ID and name, right? Or if you think that your first name and last name is unique, so let's say ID is unique, but if you feel that this combination is unique, you can just say first name and last name, and it will create this. Same. Okay. So you got a new table now, index demo. And if you look at the table, you have got like this is just a pseudo kind of a thing, right? So you got first name, you got last name, and you got score, and you got int. Why did subject not come in? Acha. Sorry, missed. Oh, the table is dropped, and let's create it again. It's done. So you can see an index demo is created, right, with all the 5 columns. Now, what is the use of primary key, right? So let's try and insert values here. So we have index demo, and we have ID. Actually, we have first name, we have last name, and we got score and we got subject and values, right? So let's say Bronny, and I'm saying the last name is Andrews. Okay. Okay. So let's insert this, and let's select it. Okay, so you got this. Now let's try and inserting the row again. If I try and insert the row again now, see, it will give me an error. Why is it giving an error? Because it is saying that unique constraint, which is demo.firstname and first name and last name, they are the same. Okay, so if I actually put Andrews, which is the correct spelling, and run it, it will work. And you can see that it is created, right? 2 rows. But if I try to put a same first name and same last name, it will give an error. Why? Because the primary key is always unique. Did we get this?
Yes.
Okay. What is the purpose? Purpose is very simple. You want to stop duplication. That's it. So if in a school, if it is students info and you really don't want duplicates of students, right? There one row should be one student. And for by mistake, somebody like us just inserts data into this. Because the primary key is the same, it will just not allow the data to get inserted. Okay. But even if I change like one small thing, the data will start getting inserted. So let's look at let me drop that table again. Okay, let's drop this table again. You don't have this now. And let me not have the constraint, right? So let's say that my this constraint is not there. So let's run this. You get a, table is created again. Let's run the first one, which is just insert a row. And let's see. So it is giving 1. Now let me insert the same row. So it's Andrews, the second one. Right? Now it will get inserted. So I get the duplication, right? I got the same thing twice. Correct? And that is a problem. So that's why we define like primary keys. Is this clear?
Yeah.
Okay. All right. So let's quickly, again, I can only show you this here. So just in my terminal. Can I increase the size? Okay. I think it was SQL less. Yeah. So this is a terminal. It's the same way of kind of running the, like accessing the, database. So here you can see schema. So the same thing that you saw here, right? The four tables, you can see the four tables here, but you can see the schema as well. Like what were the, what were the, like what are the data types? And you can see here, you'll get the key, primary key, if that was used, right? So I'll just run this again. Again, probably you won't be needing this. I'm just putting it there so that, if someone asks you, you actually know how to kind of do that. So now you have created a table, right? So let me check the schema again. English performance. Oh, I need to kind of reconnect. Why did it not get created? Or maybe I'm in a different school DB. Okay, I did not run this maybe. Oh, comma is missing. Got it. All right, so this got created. Now, if you look at the schema, you can see that the index demo table has these as a primary key. Okay.
Yes.
Okay. Now, same thing is with, how do I put it? Same thing is with foreign keys. Okay. So let's say that there are two tables that we have, which is artist and track, right? So artist and which track was there, correct? Now, to your question, Prince, right? Here, what should be the first? Identify what should be the foreign key. So each artist has an artist ID and an artist name, correct? And track has track ID, track name, and the artist name, right? Or the track artist, correct? In this case, we are not having we haven't defined a foreign key. But in this case, we are defining a foreign key. What we are saying is foreign key is track artist. And what it should reference, it should map to the artist ID in the first table here. Correct? This is very similar to what we did here. We said that in the orders table, my customer ID should map to my customers table ID column, right? That is exactly what we are referencing here. And if you want multiple such things, you can just keep adding. Right? You can add as many as many foreign keys as you want. There can be only one primary key, but you can have as many foreign keys as you want, right? So what will be the primary key here, by the way? Can anybody guess?
Oh,
Simple, right? The ID.
Yeah.
So one track can have only one ID. They can have multiple track names, right? But they can have only one track ID, and then we can have a foreign ID. Okay. So let's see if, and what will this do? We'll see that as well. So let's first create an artist table. Let's also create a track table. Okay. Syntax error near this, maybe like this is not needed. Okay, table already exists. Track. Okay. So you have this. Yeah, so you got foreign IDs right now. Now let's try and insert, right? Something. So let's say that I am inserting in artist, right? So the artist ID is 1 and the artist name is Beatles. Okay. So let's run this. Okay. And let's select star from artist. from. So we got Beatles, right? Now let's insert one more one track for Beatles. So we have track ID, we have a track name, and we have a track artist. Okay. Track artist is mapping to basically ID, right? Track ID. So maybe we do Yellow Submarine and track ID is 1, like, or the artist ID is 1, right? Let's insert this. Okay, my table is bad. Okay, so now we got track, right? We got this. What is the use of foreign key? Now, if I try and say that, okay, my artist is 2, right? And this is maybe any other Beatles song, something, right? Yeah. Actually, let's put submarine. The spelling is right. Okay. Now, if we try and do this, see, it will give an error. Why did it give an error?
Because the reference does not exist in the original table you're referencing.
Exactly. So if you look at the artist table now, because you have defined a foreign key, it says that you are trying to give me a track artist whose ID is 2. This ID is mapped to my artist ID, and there is no artist ID called 2. So I will not allow you to insert this record, right? Similar to primary key was what it was checking. Primary key was checking for duplication, right? So the foreign keys, they will check for relations or mapping or existence, right? So because tracks, so no track will be allowed to enter unless and until it has an artist ID, which is exist in the artist table, right? So now let's look at this. Let's say that I have a new artist or the same artist, because we don't have a primary key here. So I'll create Beatles and give them an ID again of 2. If you run this, now you got artist ID as 1 and 2. They have the same name. Doesn't matter to us. Now if you try and insert this, unique constraint failed track ID. Okay. I had defined a primary key as track list, right? So see, it is stopping me already. I need to change this to 2 because it's not unique. 1 already exists. Now if I insert, it will work. And now if I check, it will give me a track list. Cool. So is the concept of track, like primary key and foreign key, clear now?
Yes.
Okay. All right. So one last thing that we want to do is index. And I think I'll have to do indexing, like give an example here and only. So you can check time of, of your query that is run by saying timer on. And now you can run a query. So let's say select star from students. And you can see it gave you a real time, right? It gave you a time of this much. It basically took 0.008 seconds, correct? Let's try and do this let's do a group by or where condition, right? Select star from students where section equal to B. Again, the time was very, very less, but it kind of returned you the like only B, right? Now where, but I cannot demonstrate this. Can I demonstrate this? Okay, let's do the mystery one. Maybe like that is a slightly bigger table. Do I have the, I'm just checking where that database is. Okay, it was in the same table anyways. Mystery, right? Okay, so let's do mystery DB. So again, if I want to see all the, I just want to, which was the biggest table, Prinsa? Do you remember? The table with the most rows?
Sorry?
Do you remember which was the table with the most rows here in the mystery database?
I have to check. It's right in front of me. Let me check.
See, so in the mystery database also, you have a lot of foreign keys that are present.
Yeah.
Okay.
Keep the driver license one.
Okay, so let's do that. Select star or select count star from driver's license, right?
Yeah.
Okay. Sorry. What was the driver's license, right? Spelling driver's license.
Drivers underscores license.
Okay, so you get this, right? So there are a lot of rows here, I'm guessing. So I mean, I think probably we can demonstrate on this. Okay, there are 10,000 rows here, right? So now let's say that you are looking for like from the same this thing we are looking, but where maybe, and actually let's look at where just a minute, I just need the column names. Mystery DB. So we have driver's license, age, height, gender, date, car make, right? So let's do car make. Car make is Mercury. So there are 156 rows, right? So let's try and do timer on. Yeah, it should give you like 0.0 something seconds, right? Table. Schema. Okay, so here there is no primary, there's a primary key. As you can see, driver's license ID is the primary key. Got it? But there is no index as such, right? So let's create an index. Okay, so what does an index do? Index basically just creates groups of data so that you can access them easily, right? Let me quickly create one. Okay, so how will you do it? You say that, okay, create an index on table name. So what is my table? Actually, because I have opened it here, let me do it here. So create an index. Let's call the index name as my car make, right? Because we are searching on that. And what is the, just say car make underscore. My table name is driver's license. And my column list is essentially, I just want one index, which is car make. Okay, now you have created an index. So let's look at the schema. It's not showing here, but the index is created. For some reason, it's not showing here. Now, if you check the, again, it might not be demonstrable because it's very small. Yeah, now look at it. how much time did this query take to run? It took 0.001 second, something. Correct? And look at the system time, 0.00497. And once we create the index, how much time did it take? Real time was roughly n0, and the system time was reduced to 0.268, right? So it basically halved the time to run this. So why did this happen? Can anybody tell? What's the role of the index now? Can anybody tell?
So it just went to the one that you specified. Like whenever you searched, it just went to first to check the index and then get the data.
You're almost there. So basically, this is our table. Let's assume this is a student's table. There is no index right now. So by default, index is created on a primary ID, right? So ID is already indexed. But let's say you wanted to look at it by section, right? Which is C. So how will SQL know? SQL will go and it will say row by row that, okay, this is my section C, I will include it. This section B, I will not include it. This section C, I will include it, right? This will continue. And then it will pick all the ones. So it will search through the number of rows, which is 252 in this case. Okay. But if I create an index, let's say I create an index of section. Now section is an index. SQL will already create some kind of a temporary, in memory, it will create temporary, you can say table or database or whatever you want, right? And it will say something like this. It will look something like this. And here, let's say there are IDs that are mapped. So 5, 6, 7. And let's say this is, right? Not this, basically 8, 9, and 10. Okay. Now, if you search section is equal to C, instead of going through the entire column E, it will just go through column G. And it will say that, okay, I need C. So it will check 3 rows. It will find C and it will pick up all the values together. So instead of searching through 252 rows, it will just search through 3 rows in this case, right? Or if it is gender, it will search through only 2 rows. Let's say you create an index of gender, right, which is male and maybe female. Now here also, it has done, SQL has created these partitions by default for you already, right? And now it will just search through 2 rows. And that is how indexes work. Is it clear?
Yeah, kind of. So in this case, so it does not do a sort of group by function. I mean, so it can give different indexes to the same thing, right? For example, in the last data set, the car named Mercury, do all Mercuries have the same index, or they can have different indexes too when we create one?
So index is a column, right? So basically, you're right in a way. So what it will do here, I'll just show you. So what it will do is, so if you look at the select car make, so car make is now your index from license, right? And I will just say group by 1. So these are all the car makes that you have, correct?
Yeah.
Now what SQL will do internally to assign all of them numbers. Let's say 1, 2, 3, 4, whatever, correct? But when you now search for car make, right? When you do a where condition or you do a group by, whatever you do, right? Instead of going through all the 10,000 rows that you saw here, it will just say that car make Mercury is mapped to, let's say, index number 2, whatever, in this, car make index. In this, it will just search for Mercury. So the number of rows are reduced. Mercury here. And whatever rows are corresponding to this index now, Mercury, it will just pick up.
Okay.
Okay. Let me demonstrate it differently. Let's go to the students table here. And let's do select gender, comma, section from students, group by 1, 1,2. And let me put like a count here. So assume that you have group by. Assume that you have created indexes on gender and section. SQL will store data automatically like this. For each combination of gender and section, like female A, it will score 30 records, or sub table it will create automatically. It's like a tree, right? So 30, instead of ID, it will have a 30 rows, right?
Okay.
That's a table. Now, when you search for gender equal to female, it will first go through this gender section. But the difference is now, what the difference is, the difference is in the first one, it will go through only 6 rows. Here it will go through all 252 rows and figure out gender female. Then once we have only 3 rows female, and you say section equal to C, it will go through only 3 rows A, B, C. And now it got the combination. This data is already stored as a subset by SQL. Think of it as a temporary table, and it will just give you the 41 rows. So how many rows did it search through? It searched through 6 and 3, which is 9 rows, right? But whereas if you don't define indexes, it will search through all 252 rows once for gender, and then all 252 rows, or not 252, maybe like females were how many? Females were 80 plus 3, 110, 119, right? 119 rows for age, right? So 252 plus 119 rows. So that is the difference between indexes. Like if you index, the number of rows that it searches through reduces drastically.
Okay.
Is it clear? Think of it as if these two are indexes, then SQL stores data in this format. Like it will create sub tables or trees like this. And, so instead of storing this entire table, it does that, but it stores it in this format as well. For each combination, it will store a table for you. So it becomes easy for it to kind of search or group by when you do a select query.
Okay. Yeah.
Okay. Is it clear to everyone?
Yes.
Yes.
Are you sure, folks? Any questions? We are almost at the end of the session and end of the course. So hence I'm asking, any questions? We have covered the entire syllabus, by the way. Like this is the last thing that I wanted to cover anyways. So
yeah. The window function and indexes, I think they are pretty new to me. So what are the expectations for someone like us who are just going in, with 1 or 2 years of experience to, right away use those kind of functions?
see, I'll break that question into 2 parts. One is from an interview perspective, and from other is from a using perspective, like actually using it.
Yeah.
Generally, the way interviews will function is that you can do the same task. So we, in the example on the screen, right?
Yeah.
We did here is we figured out who are the students who got the maximum marks, or rather in which subject the student got the maximum mark, correct?
Yeah.
So they will ask you this question. You will do it using subquery. You will do it using join. And then you will see that, there are duplicates, something like that. So they'll keep asking you that, okay, can you do it using subquery? Can you do it using joins? And then they'll ask you, can you do it using maybe window functions? Correct? So they'll just test you by a variety of your knowledge as to do you know these things as to solve a problem. Correct? So that is the first part. From that perspective, I think it is good to know. So expectation would be maybe from you that you know it by how to do it using subquery and how to do it using joins. They might not expect you to do it using window functions. But if you kind of show them that you know window functions as well, it will be a plus for you.
Okay.
Like my understanding, at least in India, right? That's the level that we are looking for someone with 2 years of experience. Correct? So my suggestion would be that you practice it a bit, because knowing it doesn't, it helps only, and you might impress the interviewer. And in case they really ask you this, even if you're not able to completely solve it, even if you're kind of directionally there, it's a big plus for you, right? In terms of using it in your real work, the answer, it depends. If you have use cases like e-commerce or like financial institutions, right, where you have to calculate, so anything that has a order associated with it. For example, you take a loan and you have to pay EMIs, monthly EMIs, right? So if you have to look at the payments, like which month the payments came in, you will need like a row number or a rank, right? So it really depends on the use case that you're working on. in my experience, generally like 20% of cases requires, row number or rank, like window functions. And you can do without window functions, but because window functions are, easier, like the syntax is simpler as well as they are efficient, we use them. You can live without window functions. It's not a problem.
Okay. Okay. Thank you very much.
And just to
But
kind
they're
of
not,
add,
they're
window
not too
functions
hard.
added to SQLite like probably 1 or 2 years back. So for the longest amount of time, they did not exist in SQLite. And all the mobile apps that you used, like for Android, iOS, they use SQLite as a database.
Oh,
So,
okay.
they lived by it for like at least till, 2 years back. So it's not a requirement. But I would suggest that just, practice them from an interview perspective.
Okay. Yeah, I'll do it. Thank you very much.
Folks, any other question? Cool, then I think that was it from my side. There is one thing pending, which is SQL theoretical questions that I think Apeksha will send out to you. And as far as collating the code, I will take some time, but I will collate everything and then I'll share it with you guys ad hoc. What will be helpful is if you can drop me your email IDs, or if your email IDs are already with Apeksha, I can take it from her and send it. She can send it across to you. Okay. But in any case, if you need, like if there is any question or help that you want, this is my email address in the chat. You can email me on this, and I might be a little bit late to reply, but I'll try to reply it, as and when I get time.
Okay. Okay. Yeah. Thank you.
All right, folks. Last thing would be that we might have run a little bit faster because this is a boot camp anyways. So my suggestion is just practice. You have these databases that we used in the class, but you can use other databases as well, and just practice. I think that's the only thing that will, help you kind of get the confidence that you need. Every one of you knows how to do things. It's just, the more you practice, I think the better you will do, in terms of confidence. That's pretty much it.
Okay. Okay. Yeah. Thank you.
Yeah, definitely we need some work on Windows function. It's a new one.
And it's required, I mean, it's something new as well. So it's not expected that you will kind of get there on day one, but just try using. That's pretty much it. Nothing more to it.
Yeah.
Okay. All right, folks. Any other things for me? Any parting thoughts? Any feedback?
Yeah, it was a really nice session. You taught us really well. Thank you. Thank you very much for that.
Thank you so much, Sulabh. I'm glad you kind of enjoyed it. But yeah, any other critical feedback as well? I'm looking for it. Anything that I can improve maybe next time, that'll be really helpful. You can talk right now, or you can just drop me, an email on my email ID. It's totally fine. Okay.
So
All right. Sorry, you're saying something?
you're not part of in the group chat?
You're
In a
not.
you're not in the part of the WhatsApp group chat.
Oh no,
you
I
have-
think I'm not there. I'm not sure. Maybe like you can ask Apeksha to put me in there, or maybe like for some reason they won't. You can drop me an email. I'm responsive on emails.
Okay. Thank you.
Okay, all right, folks. It has been wonderful interacting with you guys for the guys and girls for the last 5 days. I really enjoyed it, and I really wish you all all the best and good luck with your with your journey ahead.
Okay. Okay. Thank you very much.
Right. Thank you.
Thank you.
Bye.
Thank you so much. Bye.
Thank you.